Okay,
Okay, it's happening.
cool. So FYI legal, this meeting is being recorded. Now we're covered.
For people who are watching the video, this is a live session on lesson 2 for the
R.
BVC and R group. Subject is DataFrames.
Thank you. Okay, let me just share my screen. And I think, given that not everybody raised their hand, I think we'll just go over the whole tutorial. Oh, Jacob, you have to let me share my screen.
Try now.
Yes.
Oh, good.
Okay.
Although I don't see anything. Oh, no,
Hold on.
There we go.
You see it now?
Yep, looks good.
I'm just going to move it here. Okay, so you see the RStudio Cloud? Just to verify?
Yes.
Okay, cool. All right, let's start. DataFrames. So DataFrames are basically just any Excel table. And the reason that you might want to work with tables in R versus in Excel would be because it's more reproducible. So you can run the same commands on multiple tables. You always get the same result. Also, if you've ever sorted by a column in Excel, and it accidentally did not sort one column along with all of the rest of them, that's happened to me, and you end up drawing the completely wrong conclusions, then you know that Excel is not always very reliable. I'm sorry about that. Do you mind? Thank you. Okay. Okay, so we're going to use one of the classic data sets provided by R to learn how to work with data sets. So this is the IRIS database. To load it, we run this command data iris. And now we have the IRIS data set right here. So let's look at how it's structured. Oh, and Jacob and Sarah, are you monitoring the chat and all that? Awesome.
Yes.
Okay. So STR is a really useful command. It stands for structure. It will just show you what the structure of the table is. So it tells you it's a data frame, has 100 observations. That means rows of 5 variables. That means columns. These are the names of the variables. Okay, so this is about flowers. So we have sepal length, sepal width, petal length, petal width, and then the species.
The screen sharing isn't changing on my computer. Are other people seeing the screen sharing actually doing anything?
No, not at the moment.
Oh, so you're just not seeing anything?
No, your RStudio is up. It looks like you're not doing anything with it.
It does say my screen sharing is paused. Okay.
Aha, now.
Yes.
Now we can see it.
Yes, of course, there will be technical difficulties when I'm teaching something, so just get used to it. Okay, so this is the structure of the data frame, and I hope you can see it now. It's easier to grasp if you can just look at the data. So one way to do that would be the view function that Sarah introduced last time, or you could just double click here in the global environment or click on iris, and then it opens the table right here. So you see you have your variables or your columns, and then rows with observations. And another way to just get a really quick idea of what your data frame looks like is a function called head. So when you run this, you just get the first few rows of your data frame here, and then the values for columns. Ooh, there's a lot going on in the chat. Should I be?
No, we're good.
Okay, cool. All right. Two more useful functions are the number of rows and number of columns in your data set. They're called nrow and ncol, and I think Sarah actually mentioned them in the last lesson. So when you run n row, it tells you you have 150 rows, and col tells you you have 5 columns. This is going to be useful a little later. And then if you want to know what your column names are, col names will return a vector. So basically just an array of your column names. You can do the same with row names. In this case, they're just numbers, but sometimes that could be informative. Just note that these are not actually numeric because they're in quotes. So yeah, and that will again become relevant later when we start sorting by rows. So you can change your column names. I told you that column names returns a vector, so you can set variables within that vector. So the way to access a specific value in your vector is just by telling it what number it is. So, sorry. So let's say that, let's look at the column names again. Let's say you want to change the name of the second column. So you would write col names of Iris and then access column number 2 and set it instead of sepalwidth to sepwidth. Now if I go back to my console and I use the up arrow to run col names again, you can see that the name of the second column is changed to sepwidth. Let's change it back just to make it look like it did before. Okay. Another really useful function is transposing a table. So instead of having 5 columns and 150 rows, you'd have 150 columns and 5 rows. To do that, you use the function T, which stands for transpose. So when you do that, you now have 5 rows. This is going to print the entire table. But 5 rows, and then here you have the number of the column that you're looking at, so 150 columns. This is really the place to mention what I forgot to add into this tutorial, which is, I showed you how to, sorry, is there anything, question? No, okay.
Background clattering.
Hmm?
I said background clattering.
Okay. Sorry. So I showed you how to access a specific value within a vector. Let's see how you do the same thing within a data frame. So if you wanted to change or to access a specific cell within a table, you have to tell it which row and which column it's in. So you would say you want to look at the cell in the 53rd row and then the, I don't know, 4th column. What's in there? It's the value 1.5. And that would be, I think, the petal length or petal width of whatever observation this is. So it goes rows and then columns. And I'm actually going to write it like this. Row and column. All right. So far, so good. I'll take that as a yes. Okay. So one of the most useful functions in Excel is to sort by a column. So let's learn how to do that in R. The way to do this is you specify your data frame and you use these square brackets, again, to tell it which row and column you're looking at. And then you use the function order. So in this case, you want to order the rows by the values of a specific column. So you have to put this function before the comma, okay, because you're telling it to order rows. Let's say we want to order by the petal length in decreasing order. If you didn't have this comma, it would throw an error because you didn't tell it which columns to look at. If you don't write in which columns you want to look at, then it's going to assume that you want to look at all of them. So we run that, scroll to the top of the table, and we have sorted by petal length. You see that it's in decreasing order. You also see that it kind of messed up the species column. because there's some overlap in petal length between two of these species. So let's say we want to sort it again, but we do want to maintain the structure of species. So we want to order first of all by species, and then within the species we want to sort by petal length, increasing this time, because we didn't say decreasing. We do that, and now everything is sorted by species, and the petal length here is increasing. If you wanted to do the same thing with petal length decreasing, you would just add this minus sign before that, and it would tell it to sort in decreasing order. So let's do that. And now the petal length is in decreasing order, and maintaining the species sorting as well. Questions? Okay, cool. Filtering is another super useful function. Again, you're filtering by a value of a certain column, which means that however you filter, you need to add the command before the comma, because you're looking at filtering rows where the value of a specific column is whatever. In this case, I'm filtering rows in which the sepal length is bigger than 7. So let's do that. That's a pretty small subset of our table. And they're all from the same species. Again, you can get all the data in which sepal length is greater than 7. Or you could sort by whatever, only get the Setosa species. So here it is. Here are all of your values in which species is Setosa.
Can I make
notes. Sorry?
Can I make a quick comment, Ella?
Yes, sure.
So one thing to note is that in lines 29 and 30, and I think some of the ones previous, note that every time she's executing those commands, it's printing out into the console. And so it's showing the data frame that you get out, but she's not actually setting that to anything. So like you could set like line 29 equal to iris greater than 7 or something and rename a new data frame. So just want to make note that those changes aren't actually being made into the base iris data frame. But I actually don't know about order. Order doesn't do that either, right?
I didn't do that earlier, but yeah.
But you have to save it for it to change, unless you're using, I think data table sometimes doesn't do that. For the most part. You always have to save it over into a new variable, or you can save it over itself.
I mean, these are all
let's say you wanted to save your subset of the table. So you would invent this new variable called SBST or subset, and then you would assign to that your subset. So if I did that, and now I'm just going to print subset, that's what it has. Or you can look at it here. Again, it's a data frame, the one where all the sepal lengths were bigger than 7. Good. You see questions? No, we're good?
It's a question. So the comment online, I'm just going to, there's actually a couple comments. So Haley, do you just want to ask your question? It's relevant now, or sure, I can read it out
I just had to unmute myself. The comment on line 27 indicates that you're excluding the last column from the analysis because it's non-numeric.
Oh, I'm sorry.
I was just wondering where that happened.
Yeah, sorry. That's relevant for the next thing. I put the comment in the wrong place. Yeah, good catch. I was going to change that, and then I forgot.
And then Amanda has a question as well, which I think is relevant right now. Go ahead, or I can read it if you prefer. I'm going to read the comment. So on line 30, you filtered the table to include only Setosa species. What if you wanted to filter it to include all species but Setosa? That is to exclude rather than to include. Oh, she doesn't have a mic on her computer, which is why I'm reading this question.
Gotcha. Okay, yeah, that's a great question. So I was going to point that out, but when you want to filter by a value that equals something, you have to use two equal signs here. If you wanted everything that did not equal, then you would change the first equal sign to an exclamation mark. So now you get everything that is not Setosa.
Hey, just to clarify stuff. So what happens if you run all the stuff inside of the parentheses, but not the iris with the parentheses? Why do we, or for that matter, why do we need to have iris and then iris again? What's going on with that?
I guess that's just, okay. This is what goes on with that. So if you only run what's inside the parentheses, then it's just going to give you a Boolean data frame. This just tells you where this condition applies. So we filtered for everything that's not Setosa. All of these are Setosa, so they're going to be false. And then the rest are going to be true because they're not Setosa. And then in order to get the actual values of these cells, you're going to feed this vector, really, of values back into Iris. So what you're telling it is, I want you to tell me the values of everything that's true, every row that is true. So starting from row 51 and to the end, please show me the values of all these rows. Is that helpful?
Thanks.
Cool. All right. Another thing that I do a lot in Excel is get the sum of a column or the mean value of the column. You can do the same thing for rows. So R has built-in functions for that. They're called col sums and col means. Or there's also row sums and row means. Let's just look at the columns now because that's a little more, I think, useful. So if I run col sums, sorry, this is where this comment that I had before is actually relevant. So if I was just running col sums, I'm going to run this in the console. Col sums of Iris. It's going to throw an error, and it says X must be numeric. Why is it throwing this error? Because our last column is the species name, and you can't sum up or get an average of a name of a character variable. And so in order to get what's really relevant here, which is the sum or the mean values of your numeric variables, you have to throw this column out, the last one in this case. And one of the ways that you can throw out the last column, and I know that Sarah has other suggestions for how to do that. This is how I do it. So you have the negative sign here, and then you throw out the column which is last in your vector of columns. So again, we ran this earlier. The number of columns in Iris is 5. So I'm throwing out column number 5, really. The reason I don't like to use a specific number is because I think of this a lot for count tables or OTU tables in which your last column is a taxonomy. So you always want to throw out the last column, but you might have a different number of samples on the way to that column. So if you want to have a reproducible code, then you might want to use this function as opposed to providing a specific column number. Sarah, do you want to comment on other ways to do this?
To sum by rows and columns, or to exclude
to exclude, I feel like you had some other way to do it.
Yeah, so there's a couple ways to do it.
Oh, which? You were going to show how to do it with which, I think. To throw out a column by name, not by number.
Oh, yeah. Okay, yeah. So, right, so what you're doing is you're relying on the current data structure, meaning the last column, I think, is the one you removed here, right?
Mm-hmm.
So another option is to actually name the column. So if you type in names iris, yeah, so then which one are we're excluding species, right?
We want to exclude species.
Yeah, so if you want to select that column for removal, that's a more permanent change to the iris data frame. You can do iris $ equals null.
I am going to throw iris into a temporary, or I'm going to create a temporary table called temp, just so that I don't mess with the iris data. But so you would do iris and species null, like this. Oops, sorry.
Yes.
Okay.
You need to do that on temp, actually. Oh, yeah.
Ah,
Yeah.
crap.
So, no, it's okay. It's on iris. So you can
Okay, I'll just.
That's right. Yeah, exactly. So, yeah, and so I prefer this way, and there's other ways to, right, instead of selecting a column and marking it null and then removing it, there's also ways to select columns by name. So there's a way, a longer, more typing would include, you know, temp equals, and then you're selecting the columns sepal length, width, petal length, petal width, and then not species, and using which. And so that's another way to do it, just to make a comment on if you're using the numbers or relying on the order of those columns. That's what line 33 and 34 are relying on. That's all.
Right. So if you look at the console now, I'm using a function called which is what Sarah was just explaining. And I'm just looking at which column in iris is named species. And it's going to say 5. So if I wanted to, I could just replace this by this. And it would do the same thing.
Or you could replace it with the number 5 too, right?
Yeah, so that's what I was talking about, I think, earlier, where if you use a specific number, then you have to always have the exact same data structure, as opposed to a varying number of columns. Okay. Questions before I move to OTU tables? Okay. So we talked about OTU tables. I did give you a sample, tiny sample OTU table here, just so that we can talk about all sorts of functions that are really useful for that. So let's read the table with the function read CSV. And I'm just reading the CSV file that I provided here. Let's look at the structure of this table. So it has the OTU ID, and then there are 6 samples, and then the taxonomy of the OTU. So if I run head OTUs, okay, that's not useful. Let's just look at this table here. So I have the OTU ID here, and then the counts in each sample, and then the taxonomy of the OTU. That's what it looks like. Okay. So one of the most common things that I do with OTU tables is converting them from counts to relative abundance. And there are a number of ways to do that. It's really a lot easier when you're not just using base R, but when you're using packages, but we're going to talk about that later, or in the next lesson maybe. But if you only want to use base R, here's how you would do it. So you want the column sums, because you're going to divide the value in each cell of each column by the sum of the column to get the relative abundance. But But you don't want to do this on OTU ID or on the taxonomy, because it's going to throw an error. So you are going to exclude these columns from your analysis, and then you're going to run colsums, and then you're going to save that into a vector, which I just randomly named vec, but you can call it whatever you want. So if you run that, here is vec. Let's look at it. So these are the counts that you have in each one of your columns. This is what you're going to divide your cells by. Okay, so let's convert to relative abundance. Just to maintain the same table structure, I'm going to save this table into another table that I called relabun, or relative abundance, but I'm going to change the values in there. So the first way to approach this is with a for loop, in which I'm going to go row by row and divide the values in that row by the vector. And R already knows how to divide the first cell by the first sum and the second cell by the second sum, etc. I do not recommend using for loops for large tables. It's going to be super slow, but you can do it. It will work eventually. So what I'm doing here is I'm going for every row, or R, in 1 through the number of rows of relative abundance, or relabun. This is the sign for starting what you're going to do in your loop. And what I'm going to do is this. I am going to assign into row R, and then I'm, again, excluding the non-numeric columns. What I'm assigning into it is the value of these cells divided by my colsums vector. So let's see what that does. Okay. Now if I look at, okay, I have to stop using head because of taxonomy, but now what we have here is we still have our OTU ID, but for each OTU, or for each column here, we have relative abundance or fraction information. So this isn't percentage. If you wanted percentage, then you could just multiply the value of each cell by 100, and then it looks like percentage. So this is how you would do it. You would take all of your numeric columns and just multiply them by 100. We do that. When we go into relative abundance, we now have the same numbers, but they look like percentages. Good? Yes, no, yes, no. Okay. I'm going to assume silence means it's good. Okay, so Haley, to your question, how do we do this with apply? Apply is a really useful function. It's not the friendliest that I've ever worked with, but once you get used to it, it's really great because it's a lot faster than running loops. So I'm going to just start over. What I'm doing here is I am defining a function. This is what I'm going to do to each row of my data set. I'm sorry, my assistant is here again. So I'm going to call this row, excuse me, div by colsum, or divide by the column sum. And I'm assigning this to this. I'm assigning a function that accepts x. In this case, x will be a vector, but of course, R doesn't know that at this point. It's just assuming it's going to be something. And it returns x divided by the vector that I defined earlier. So this is what apply is going to do to each one of the rows of my data. And now what I'm doing here is assigning into relabun the function, or the result of apply. I'm sorry. Excuse me. I am going to give apply the table OTUs. And again, I'm excluding the non-numeric columns. Then comma 1. 1 means you're going to go row by row. If you want to go column by column instead, then you would put 2 in here. In this case, I'm going row by row, so I'm giving it 1, and then the function that it's going to perform is the function that I just defined, divide by column. I see a lot of chat stuff going on. Is that,
We're unpacking a
Is it
statement
not
from a
clear?
lot earlier.
okay. All right. So let's run this. Ooh, I forgot to define the function. I'm going to run this. Okay. And let's look at relevant again. And whoops, it really doesn't look like we expected, because instead of the samples being columns, they are now rows, and then all the numbers are in fraction again. So this is really not what we were going for. So maybe the first thing that we want to do is transpose the table. So I'm just taking everything that I wrote before, putting it into parentheses, and then adding T for transpose in the beginning. Let's do that. And now, at least my samples are in columns, but I'm missing the OTU ID and I'm missing the taxonomy. So, and also it's not a data frame at this point, it's a matrix, which is a slightly different data type. We're not going to get into this right now. For it to be really like an Excel table, it needs to be a data frame. So I'm taking everything that I did here, putting it in parentheses and adding as data frame in the beginning. All right, so now if I run str for structure, relevant is a data frame with 9 observations or 9 rows of 6 variables or 6 columns, and they're each numeric. I still don't have the OTU ID or the taxonomy. So what do I do about that? What I can do is I can merge my relative abundance data frame with the original OTU table that had the taxonomy and the OTU number. But in order to merge 2 tables, you have to tell them what's in common between the 2 of them. So in this case, we don't have a column that is present in both tables. So we're just going to merge them according to the row number, or row names in this case. So if you remember, the row names were strings, they were not numbers. So this should work. So I am merging these 2 tables into relevant 2. It's worked before. Okay.
Ella, can you go back a little bit?
Yes.
We're talking about, so when you ran the apply function,
Yes.
why did you then transpose the output of the apply function? And what is the output of apply that means that it needs to be transposed? I'm thinking about like line 75 here.
Yep, let's go back to that. So this is the first time that we ran apply. I'm going to run it again. And now we're going to look at our table. And we kind of wanted our sample names to be in columns like they were in the OTU table. But apply transposes the table. So
why did it do that? And what's going on there even? I've never used apply this way. When I run apply, it's almost always I get a single list out as opposed to another table. I've never seen this, but so why doesn't it transpose the data frame?
Excellent question. Wish I knew the answer. It just does.
So is it always going to be kind of the opposite order of the way you want it?
Yeah.
Okay.
Okay. So let's see if this cancels the error that I was getting. Yes. Okay. So I merged my tables. That didn't work very well.
Okay, there's a comment that from Haley that says, I think just the 2 on the first element after merge needs to be removed. So it's not relevant 2, it's relevant.
Right. Good catch.
Nice.
Ooh, Damn, Haley's good. Okay, so let's look at relevant 2. Now it has all of our samples with the relative abundance, the OTU ID. Then once again, it has all of the samples, but this time with counts and then taxonomy. So we don't really want the counts to be there, right? We just want our OTU ID and our taxonomy. So what we're gonna do is, once again, we're gonna merge our relative abundance table with the OTUs table, except this time, we're only going to include the columns of OTU ID and taxonomy. So what happens if we do that? Let's look at relevant 2. Here are all of our samples and OTU ID and taxonomy. This is kind of more like it. And you can throw out the row columns either like this, or the way Sarah was showing it before was oh, sorry. Row names, no. So now when we look at the table, it's not going to have the row names. Okay. What if we wanted to merge 2 tables that have a column in common that has unique IDs? So for example, your OTU IDs would be in both tables and you just want to merge them to get your taxonomy. So let's define this table relevant 3. It's going to have only the OTU ID and then the samples, the relative abundance from samples. And we're going to define another table that's going to have only the OTU ID and the taxonomy. So let's look at them. Here we have all of our relative abundances and the OTU ID. And here we only have OTU ID and taxonomy. So we want to merge those 2 tables by OTU ID, obviously. How do we do that? We use the same merge function, except this time we tell it to merge by OTU ID. This is just the name of the column. We run that. Boom, we have our OTU ID, our samples, and our taxonomy, which is really what we wanted to begin with. What if, so in this case, the column OTU ID, it had the same name in both tables. What if it had a different name in those tables? So what I'm going to do is in the second table, I'm going to rename that column George. So if we look at that table now, it says George instead of OTU ID. So now I have to tell merge which columns to look for in each table. So we have our first table and our second table. And so in the first table, the column was called OTU ID, and then the second table, it was named George. I know that these columns are the same. So I can once again run merge, and surprisingly, R knows how to merge these tables. I think that's all I had. So what questions do we have?
Question for Brittany. Why is there always a, wait, where did it go? Oh, why is there always a comma starting off in the brackets? Like relevant 2 is saved as relevant 2, comma 1.
Here?
Yeah.
Okay.
What would we just remove that comma, for instance?
Okay, let's see what happens. I'm gonna run this in the console. What did it do? It's an excellent question. The reason there is a comma is because I am telling it to throw out the first column. So if I wanted to tell it to throw out the first row, I would put this before the comma. This goes back to the beginning when we were talking about how to access specific cells in the data frame. And so the row would come before the comma and the col would come after.
It defaults.
So whenever I'm, referring to, I want all the rows, but I don't want the last column. This is how I would do it.
So it defaults to 0.
It defaults to column.
To column, okay.
Yeah, so it's like, I prefer to put commas in because then it's like not, it's more exact, I guess, but that's like a style thing.
And the reason that you don't need that, so the way that R stores data frames is it treats them as a list, right? So they're basically a list of columns. And so if we say number 3 of if we just say relevant brackets 3, this is take the third element of this list. But whereas if we do comma 3, that says specifically take the third column, which happens to be synonymous. Whereas we say if we take the third, if we do 3 comma, then we take the third row. If we do 3 comma 3, then we take the third column of the third row, and that'll be some particular number out of the middle of the table.
Right. Yeah, I guess it's more organized this way, but if you're
almost always I leave the commas in for clarity.
Yeah. Anything else? Will you stop assisting?
Just one comment, the merge help menu is really helpful. Whenever I use it, I end up needing to pull that up. There's a lot of other options in there. If you consider you're merging 2 tables, you have to think about like if there's duplicates or if one table doesn't have something. You can also merge it so the product ends up being whatever was present in 2 tables, right? So if you want to look for things that were shared between the 2 tables, so there's different settings you can do in there. So definitely pull up the help menu.
To get to the help menu, you would type $merge and then enter. And this is your help menu. I have, well, when I started using R, I found help menus kind of scary because I didn't quite understand their structure. But basically, they tell you the usage. So in this case, you're merging table X and table Y. We talked about by. We talked about by.x, which is the column in the first table that you're using as an index, and then by.y is in the second table. This is what Sarah was talking about, is exclude duplicates. You can sort your tables. And then if you find all of this kind of intimidating, you can scroll all the way down to the bottom and just look at examples. And I think these are a little friendlier. And also, do not be afraid to Google stuff, because Stack Overflow is your friend, Google is your friend. Every question that you might have, as basic as it may be, you can be absolutely sure that somebody posted it on a forum in the internet before, and you can find the answer there.
Can we run through one of the examples that's built into it, just to see how that would work?
Yeah, sure. Let's pick the first one. Hold on, sorry. Trying to figure out where it ends. So it goes all the way down to here. Ooh. Okay, let's start from the beginning. I'm just copy pasting. So now we have a table called authors, and it looks like this: surname, nationality, whether or not they're deceased. And then, oops, sorry. And then author N. It's going to be the same thing. They just changed the name of the column surname to name, I guess. These are probably going to be the books they published. Oh, I keep forgetting that this is not actually code. Okay, so we have books, and then we have the author name. So we can merge the authors and the books. Hmm. Interesting. What's other author? Where did that come from? Oh, that came from the books. Okay. Do you want me to run the rest of them, or?
Yeah. So I'm not actually clear why that even worked, right? Because merge defaults to using the row names to merge things by, right? And the row names in both these both these tables are 1 through 5.
I don't know that it
I don't think
defaults
it
to the row
defaults.
names. I think it defaults to if you have a
Finding
common column name.
Okay, great.
Yeah.
So if you don't identify it, so if you're doing author and they happen to have the same column called names, and it's able to merge the two. But authors doesn't, right? It's where the variable
Right.
with books is called names, with authors is called surnames. So there you have to specify the thing in the
Right.
authors table is called surname, the other one's called name.
So that would be, yes. So that would be the next line, and then the last one.
They flip it.
Right.
Oh geez.
Oh, I have to run this first.
And you'll notice that they're saving it as M1, but then they put that whole darn thing in parentheses, and that means that it both saves and prints at the same time. That's why they're doing that.
That's good to know. I didn't know that. So there you go. All right, let's look at M2. I don't even know what that did.
Lots of things.
Yeah.
If anybody wants extra credit for this course, we give 10 bonus points. Anybody who can figure out what that mess of code does.
Yes.
We've got a couple questions over the chat.
Okay.
First question is, what if you only wanted a particular column from table 2? Like you only wanted titles in this example.
Like to subset only titles?
So
you only want a
can
particular. So we've done. Yeah, I think you can just do the same subsetting that we did before, right? So we could do. It'd be like.
So once you have this table, you just want to print out.
Yeah. So yeah, you want to merge it and just know what I guess. So is that actually your question? Let's just...
So I just want to know. So you're merging by name, and suppose you only wanted one particular column to merge with the first table.
Oh, right. Okay. Yeah, we did do that earlier.
Sorry,
So
I might have missed it.
we were merging. The first thing that we did is we merged the counts table and the relative abundance. And then we had both in the final table. And we don't want that. So we went here and we merged our relative abundance table with only these 2 columns from the OTU table.
So when you write the first 2 variables that are required in the merge command are your 2 data frames that you're putting in. And instead of just the data frame name, you can also designate one of those data frames to just select the columns within that. And so that's what's in the brackets and all the parentheses here.
Yeah.
Okay, thank you.
What I'm giving it here is a vector. Okay, C is creating a vector. What does C stand for?
Concatenate.
Ooh, okay, good to know. All right, so I'm giving it a vector that includes the number 1, and then the number of columns in the OTU table, that's going to be the last column, the number of the last column, right? That's going to be 8. So this is the vector that contains the number 1 and 8, which tells, because it comes after the comma, it's telling R that I want a subset of OTU's table with all the rows and only columns 1 and 8. Good?
Yes, thank you.
There's another question, if we can take it, and we do have to wrap up at 5. The question is, can we go over? And I think this is fair. Can we go over the apply function again? This is Brittany. She says, I think Jacob said that he didn't use it the way Ella was using it here. So what are the ways that it was used? So often when I'm using the apply function, I usually give it a table, and you tell it whether you're operating over the rows or the columns and the thing that you do. So often when I'm using apply, I'll do something like I've never actually used the call sums function before, for instance. So I would do apply and then the name of my table, and I'd say I want to get the column. So then you specify, if you question mark apply, it'll tell you the command. So I have to specify the margin. So I say the margin are the rows, which I think is 1. No, sorry, columns, I'd say 2. I want to do it over every one of the columns, and then I give it the function that I want it to do. So usually the function that I would do would be like sum. But Ella was doing a function that instead of just returning one thing would return a vector of things. And so for each one of the things, it gave you several different things as opposed to just one thing, the way that I often do it.
Right, so if you go to the apply help menu is one of the most confusing, I think, that R has. Because it's so versatile, and there are multiple functions that are built on top of apply that are supposed to make your life easier if you have a specific type of data. So let's just scroll to the bottom, because that's gonna make it easier. So here we have whatever, a data frame. We're running apply on this data frame. We're going column by column. That's why it says 2. And then we want the mean. And you can also, you can give it multiple functions, I think. Let's see what happens when you do this. Okay, so X looked like this. And then what I'm doing is I'm getting the average of each column. What does trim point to do? Does anybody know?
I think it truncates your you know what, I may be making this up. I think it takes an average and then it
Oh, the decimal point?
that's what I thought, but now that I think about it, why would it be 0.2? Try it without it, see what happens.
Okay.
That's what I always do.
Same thing.
So
Okay.
somewhere in the apply documentation, there will be the word trim, and if you dig around in there, you can probably figure out what that actually means.
So actually, here's a really useful part. We're doing apply, giving it the data frame, going column by column, and the function that we're using is sum. Sum is a built-in function in R that just sums up numbers. And so this would be the equivalent of running call sums X. And hopefully that clarified things a little bit. I think we need to wrap up at this point, but if you have any more questions, we'll have office hours on Friday, and feel free to post questions on the Slack channel. We're really happy to answer them, and we're staying on top of things more or less.
Oh, one more thing. I just looked at the apply function, and if you look all over the documentation, trim isn't actually a thing in the apply function. Rather, apply passes a bunch of variables to the mean function, and one of those is trim. So trim is a variable that goes to mean, and you put that into the apply function to say, pass that to the function inside of it. We can dig into that more in future lessons.
Cool.
Yeah,
Thank you,
so 2 quick comments to end is that I think that we'll continue going over like data wrangling, and we're collecting questions that are in the Slack channel. I'll go over the questions from this chat as well. And I think we'll kind of go over some of the same things that we're going over today, but a different approach. That's because there's a lot of different ways to do something. I don't actually use apply very often. I find it very confusing, but I do end up using it in some instances. So maybe I can pull up when I use it and when I don't use it. So if anyone has a comment on that, but and then the other thing is on Friday office hours, I think whoever is instructing will probably share their, like I know I will do it, and we'll share our screens and show you how we run R. I know we're using RStudio Cloud for the class, but there's lots of different ways to run R on your computer locally or from a remote server. So I think just sharing how we do it might be a good example for everybody. Cool. Anything to close, Ella?
Thanks for attending. Hopefully it was semi-helpful.
Thank you, everyone.
No.
All right.
All right.
Bye.
Bye.
Thanks both.